Hello, and welcome to Expected Value, the podcast that goes inside the sports analytics world. I'm Paul Carr from True Media Networks. This week, we have something a little bit different for you. I spent last weekend in Boston at the New England Symposium on Statistics in Sports, commonly called NESSIS, listening to presentations and talking with people way smarter than me about the latest research in the field of sports analytics. It's a great one-day conference hosted at Harvard every other year since 2007, with presentations ranging from football, soccer, and baseball to esports and marathon running even. While I was there, I recorded conversations with 4 of the presenters. 2 of those conversations are on this episode, and 2 others will be out in another episode later this week. For this episode, we'll focus on football, specifically the NFL, with guests Ron Yurko and Dani Chu, who both presented at the NESSIS conference. Ron Yurko's up first. He has both bachelor's and master's degrees in stats from Carnegie Mellon University, where he's currently a PhD candidate. He also founded the Carnegie Mellon Sports Analytics Club as an undergrad and is now an advisor for the club. He's one of the creators of NFL Scraper, a free R stats package for accessing NFL play-by-play data, and he's been at the forefront of public NFL analytics for several years. Ron and I will talk about his excellent NESSIS presentation, which was entitled Going Deep, Models for Continuous Time Within Play Valuation of Game Outcomes in American Football with Tracking Data. He'll explain that better than I can. It's basically a building block to develop in-play expected points and win probability models to go even deeper than the usual pre- and post-play models. So without further ado, here's the Expected Value conversation with Ron Yurko. Talking with Ron Yurko from Carnegie Mellon University. His presentation here at the NESSIS conference was called Going Deep, Models for Continuous Time Within Play Valuation of Game Outcomes in American Football with Tracking Data. So first of all, Ron, let's kind of translate that into kind of exactly what it means and what the gist of it was.
Yeah, thanks for having me. So the whole idea of doing this continuous time modeling is what we already have currently in football work and football analytics, what's called expected points and win probability. And that's at the start of a play, how many points is a team expected to score, or how likely are they to win the game? What we were really interested in is taking work that's been done previously in basketball and soccer and seeing how does the value of, say, the expected points or win probability change over the course of the play, given decision-making that's taking place, maybe based on how the quarterback is moving, who they target, when the running back gets the ball, how far they go, where we expect them to land, and the final ending yard line of their carry. That was the basis of what this project was about, was within the play itself, how is the value changing over time, like a stock ticker movement.
And so as you do that, you're seeing, okay, when this guy got this far down the field and there were this many players in the way, what were the takeaways that you kind of saw as you went about this process?
Well, the first main takeaway I would say is that tracking data is very difficult to work with to start with. And we were grateful for the fact that this was a subset of data released to us by the NFL through the Big Data Bowl. It was the only reason why this project was even possible. And so we could extend what we were doing with publicly available data with expected points win probability and now try to do something of, let's come up with a framework to simplify the problem of dealing with all this XY speed information at the 10th of a second level. How do we get continuous time value? And we came up with a general framework of we're going to predict the end of yard line for a play, since that's all that determines really the value. That then updates what's the down, what's the yards to go. And so from there, there's all these pieces that if you have just any sort of general play of what could take place, if you model the various decision making, and it fundamentally then came down to, we're just going to focus on predicting the end of yard line for running plays to start with.
So you touched on a little bit there about some of the things you can build on this or the future applications of something like this once you continue to fine tune it. What are kind of the top couple things that would be on your list if you're looking at what you've done so far and what you could do next?
And so definitely the top thing is actually implementing the full framework. So during my NESSIS presentation, I showed this slide, and it's also online in our paper, Going Deep. It's on the archive, where we have all of these steps of going from a drop back to then modeling who they're targeting to a global, is anybody going to catch it, to then who catches it, but then fundamentally the ball carrier piece. And we've implemented our version so far of the ball carrier model, but there's all those other pieces, taking advantage of, say, what Brian Burke has developed at ESPN with DeepQB and others that have come out of the Big Data Bowl as well. And the other big thing was something I touched at the end of the presentation, of rather just than predicting a single yard line where I think the running play is going to end up, I can predict a whole distribution. I can draw a curve over the field where I think a player is more likely to end up. And so this example play I went through, you could see where he was likely, based on fitting a whole curve, you could see, oh, he's kind of likely to end up maybe near him, but now he's also getting more likely to reach the end zone. So the average wasn't appropriate because it was really a bimodal distribution on the field itself. So that's really in the next step as well.
What's the player valuation thing? Because I can see, you mentioned decision making, who's good at this, who's bad at that, whatever. What's the player evaluation future as this data and these tools like this get developed?
Yeah, so one of the things I talked about within the presentation was if you're just predicting even the end of yard line, you could say, all right, given they received the handoff and you know everything about where the players are at in the field at the current moment, where are they expected to go? Does that player reach that point? Does he fall short? Does he go beyond? You could do things within the rest of that play as well. And if you look at, okay, maybe a second into the play where now players are lined up in their blocks, et cetera, where do we think the running back is expected to go? Does he go beyond that? Does he fall short of that? And then we evaluate things with respect to, all right, do we think they're going to get the first down? Do they think they're going to get the touchdown and whatnot? And do players reach these expectations? And then in the continuous time framework, once with expected points and win probability values, we can look at the actual true values of player decision making at the various position levels. So there's been this discussion within football analytics on the value of pass rushing versus pass defending. So with a full framework and where you're actually computing expected points and win probability at the frame level, then you could really see, okay, how much is the impact of a corner's movement in, say, following his defender, or the corner defending this pass? How much value does that have versus, say, the pass rusher getting some more pressure on the quarterback, right? We can actually quantify that because people have done analysis, say with charting data and whatnot, but now we want to actually quantify the continuous time level version of it.
Yeah, it's interesting. I can see, we have these XYAC models and things like that, and this seems like a next step, a nice next evolution that you can add more on, use it for different positions, things like that. I want to ask you about something you said right before we started recording about how the sports analytics community world, whatever, has grown in acceptance or has been accepted more by, we'll say, the general analytics world over the last, you said, 5 years or so. What do you mean by that, and kind of explain what's changed over the last 5 years?
Yeah, so initially I would say no one would disagree about, say, using sports data sets as a teaching purpose. And largely, maybe in the academic community, it would be considered, you're just doing a sports thing for fun, not necessarily taken seriously. But now with the evolution of the type of data, such as tracking data, comes with very difficult problems, very complex situations that you're going to need to develop statistical methodology to handle. And that's led to new publications, and not just in the sports realm, but for instance, the Cervone-Bourne work was published in Journal of American Statistical Association, a very good statistics journal. They breaking down the continuous time value within a basketball possession, right? And so you see it growing more and more in terms of it's becoming more embraced within universities itself. And like in our department at CMU, our undergrad head, Rebecca Nugent's, really embraced it. And we had a summer program with students working on projects all focused on sports analytics. The idea being this could be a great avenue of research, of getting involved in statistics, and it's complicated problems.
So because there's more data and better data, and you're not just working with, we'll call it box score data, it's more applicable in some ways, or the methodology is more applicable to statistical worlds beyond just sports. That That'd be fair to say.
Yeah, absolutely. And you because of the complexity, right, it's going to introduce novelties, which academics love novelties, right?
Ooh, it's new. We get to figure out a new way to mess with something or a new toy to play with, right? All right, Ron Yurko from Carnegie Mellon, thanks for joining us here on Expected Value. Thanks to Ron Yurko, PhD candidate at Carnegie Mellon University, talking about his presentation at NESSIS. You can follow him on Twitter at @stat_Ron. Our next guest here on Expected Value is Dani Chu, a master's student at Simon Fraser University in Vancouver. Dani has been a graduate intern in the NBA's Basketball Strategy and Analytics Department, and earlier this year, his team won the college division of the NFL's Big Data Bowl. Based on that work, his NESSIS presentation was entitled Route Identification in the NFL, as he used player tracking data to classify route types and route combinations for players and teams. Here's my conversation from NESSIS with Dani Chu. We're joined now by Dani Chu, master's student at Simon Fraser University in Vancouver. He did a presentation here at NESSIS on route identification in the National Football League. Dani, welcome to the show. Let's kind of talk about how you got into this topic. It was part of NFL's Big Data Bowl. Tell us what that is and what that process was like for you getting involved in it.
Right. Thanks for having me. So the process, the Big Data Bowl, was the inaugural event that was hosted last winter, and it released 6 weeks of tracking data to the public to analyze. And the goals were to promote public analyst talent, and also give teams ideas of what they could be doing with the tracking data. And so we had roughly 20 days to complete the project once we got the data. Ended up only being 11 for our group because of Christmas and other job applications and stuff like that. So we really had to scramble and put together something in 11 days, but really just tried to provide proof of concept for a couple of different ideas, a couple of different use cases. And then when we found out that we got accepted, we then cleaned those up and made sure that we were able to present it in a cohesive manner to football minds that might not just understand the data side of what we did. And so really just tried to incorporate game film and real life scenarios that they could break down.
So you were given this large amount of data, and as I understand it, 2 or 3 tracks of kind of, you can go this direction, this direction, this direction. How did you pick route identification? Like what made you and your team decide this is what we're going to focus on here?
Right. So there were 3 things we could choose from. The first one was propose a rule change. The second one was how to use speed or analyze speed, or how do players use speed. And the third one was optimal route combinations. So we found optimal route combinations as the most statistically challenging problem and the most actionable item for a football team. And so that was kind of our decision in choosing that. The route identification that I presented today was only a small subset of the actual full NFL project, because the Big Data Bowl project actually incorporated the optimal route combinations that needed the route identification part. This was just the most statistically succinct for this conference.
I guess we should point out that, first of all, you and your team won the college section of the Big Data Bowl. And then we've kind of talked around this, but what exactly route identification in the NFL is sort of self-describing, but tell me just generally, what's the kind of elevator pitch of what your project was and what you ended up with?
Right. And so right now, route identification is mostly done by assistant coaches, at least at the college level, from what I understand. NFL, there might be other people who are paid to do it, but it's a manual job. And so our idea was, from data, can we identify routes themselves? And this is looking at the patterns and movements of the players on the field and comparing those patterns to each other. So we had no labels for our data, and we had to come up with the labels based on the shape of the route. That was the main issue, is that we didn't really have these labels. And so we had to use a clustering technique to group similar trajectories or similar player movements together, and then use our football knowledge to then label those trajectories as a post or as a go or as an out.
So if you're taking this, what you've done so far, and a team, this is kind of what you did, I think, at the Big Data Bowl. A team comes to you and it's like, hey, this is really cool. What do I do with it? How do we use it? So what's your pitch to a team on how this can make their life easier?
Right. So I think this route identification stuff is really the baseline of what we want to use. It's giving us a language and a tool to then go into further analysis. So some of the motivations I used were or our team used is for receiver statistics, so being able to account for usage. You could also look at possible new quarterback statistics or even defensive statistics. If you were to do this for other positions, you could almost start to parse out man versus zone identification or different offensive line movements. And so like this language of movements now gives you objects with which you can do further evaluation that add context that coach might be mad that you're missing out on when you do your original analysis.
And then how about, you talked about the route combinations. So once you identify them, how do they mix together? What did you do to get to that? And what did you kind of learn from the route combination work?
Right. So that is very preliminary work and really a proof of concept of idea. I'm not ready, or we're not ready to rewrite a coach's playbook or even suggest a play yet. It was really this really rudimentary baseline version of, hey, here's a way that now that we have route labels, we could do this. And part of optimal route combinations is knowing what the coach was trying to do on the play. So we could infer what they should be doing on the play, but that's a different question to ask. And so really, I think if you're working with a team, now you can start to have conversations about, hey, what is the goal of this play? What are you trying to design out of this play? Is this a decoy route, or what reads are being made throughout the route? Or throughout the play. And so you can sort of use these tools for play design in that sense if you have that coach and inside information. But without knowing the goal of the actual play, it's a little bit harder to assign credit to routes for what they did, because you're putting your own idea on what they were trying to do, and that's not really the best way to do it.
What did you learn? And this is the first time a lot of this NFL data, play-by-play data, was public. What did you learn, or what surprised you just about, you're seeing this data for the first time and you had to figure out what to do with it. So what did you learn or take away from dealing with a whole completely new type of data?
Right, yeah. So the tracking data was we were the first public analysts to get our hands on it, along with the rest of the Big Data Bowl participants. And it was actually, on the surprising side, it was surprisingly clean. There were a little bit of issues with the way that players were facing, but overall the locations were really clean, and you don't really see that in a lot of sports data sets in general. But a lot of tracking data can be quite noisy, and so this was really nice to work with. But then just the magnitude of it, you're going to get into working with big data. You know that you're only dealing with a small subset, but still you really have to find ways to manage that size of data. And if you think about it, this is only the first 6 weeks of 2017. They now have 2 more seasons worth of data. It's growing by the week. So thinking about how teams are having to build data management tools to account for that much data. And really, if you want to do analysis, you need more and more data, because even if you have 1,000 rows, that might only describe a certain number of routes, or that only might describe a certain number of plays. So you are having exponentially more amounts of data per play, but you're not getting more plays. And so really you need more plays of data to be able to come to some better conclusions. And so even though you have more data and you're able to do a better analysis, you still have to wait for so much more to come in to really take your analysis to the next level. And so thinking about how you're going to go through 3 years worth of data, which now is coming into almost billions of rows, is just mind-blowing, right?
So what's next? You talked a little bit about how the route identification leads to route combinations and things like that. What would you see as some next steps extension-wise for what you've done so far?
Right. So our project in its current form was for eligible receivers. We were able to do some extensions to that work with the NFL this summer and doing it for other positions. And we think that's a really cool, unique problem, and so we had some really unique results from it. The other step, our work is motivated by a paper in basketball, and they have this first part where they identify trajectories. They do the second thing where they use those the identified trajectories as a language of words, and then they do topic modeling on top of that to get play design. And so you could do this with receivers quite well, and it's what we did in the Big Data Bowl, but you could also do this on defensive schemes, on offensive line movements, on all sorts of different combinations. I think that would be a really interesting way to take this. You can do cool defensive and offensive adjustments to statistics that we already have. It's really just the baseline use, and now you have this language that can be extrapolated into a bunch of different projects or scenarios.
Great, sounds good. Dani Chu, master student at Simon Fraser, thanks for joining us here on Expected Value. Thanks to Dani Chu for joining us at the NESSIS conference last weekend in Boston. You can follow Dani on Twitter at ChuYurVeg. That's spelled CHUYurVEG, CHUYurVEG, to follow Dani Chu on Twitter. I'm joined now in the True Media Network studios by Albert Larcata, True Media's Senior Director of Business Development and Data Science. Albert, you were also at NESSIS last weekend with me. You were at Ron's presentation. You heard the interview. You've also seen this NFL tracking data for the last few years as True Media has processed it for NFL teams. What do you think kind of about Ron's presentation and the direction that analytics, especially in the public sphere, is going with this new tracking data?
Yeah, so Ron's presentation was awesome, as expected. Ron's a sharp guy. I've gotten to know him a little bit the last year or two. We had an internship at True Media, Carnegie Mellon internship that we helped out with last year. So Ron's great. So it's funny. My biggest takeaway from his presentation was almost this little throwaway slide he had that he spent, 20 seconds on, which was essentially a flow chart of a football play laying out, after snap, what happens next, the different branches a play could go with quarterbacks or ball carriers and all that. And like each of those sort of boxes in that flow chart is like a year's worth of analytics development work to model correctly. The angle he took was the ball carrier route. So once a rusher or a receiver has the ball in his possession, what's the expected yard line? And then the novel approach was the distribution of the expected yard line that he eventually gets tackled at or goes out of bounds or scores. So, which is great. Like that's a key part of it. And it's a requirement to, get the play right. But like, it's just, it's crazy how much work still needs to be done with each of those individual models and the transition probabilities of going from, quarterback has the ball, he can pass it to this receiver or that receiver, he can scramble left or right, he could get sacked. Like there's so many things going on that all need their own attention and their own model. And it's just, I know he knows this too, but that little flow chart he made that I think he said it took him like months to even come up with that flow chart, which is probably true. Like it's hard to do that. The work required to kind of get that flow chart working from a framework and having models to, get at each of those steps is, it's a lot of work. So the part Ron tackled was great though.
I was interested by not just his presentation, not just Danny's, but there were so many presentations where what they did, had a lot of building blocks in it that can be used for a lot of other things. And their presentation itself could kind of be built upon to do a lot more stuff. Like Danny's was basically about identifying routes. And that seems kind of elementary. Like you could have coaches watch tape, scouts watch tape, and just about do a similar thing without tracking data. But by automating it, like Danny did, you do it faster and you create this building block for so much more. You can identify route combinations that do and don't work. You can do likelihood of certain routes in certain situations, etc. All of these are things that coaches do already to some extent, whether it's like explicitly charting plays or you just kind of know in your head, he's likely to run a slant on 3rd and 7 or whatever it is. So these things are happening already in a kind of a non-analytics way in a sense. And this makes doing that so much more easier and so much more powerful for teams to be able to use and for the public to be able to see.
Mm-hmm. Yep. And it goes back to, I know we had Mike Lopez on a couple of weeks ago, but so much of this is a thanks to him for getting people like Ron and Danny and a lot of others there, the data, so that the frameworks and ideas these guys had in their minds, I'm sure before the data even came out, they're able to act upon it and start the movement towards the answering of those questions from Ron's flowchart.
Right. It's exciting to see all these things just out there because I'm sure some teams are doing things like this to some extent, but obviously we're never going to see it if it's a team because they're doing it for their own private use, which is understandable. But now football is starting to, kind of be where baseball was a decade ago in the sense that this public data is getting worked on and shown, and it's just going to keep building understanding, knowledge, and an enjoyment of the game to some extent. All right, thanks, Albert. That will wrap up the first of 2 podcasts featuring interviews from last weekend's NESSIS conference. Later this week, we'll talk with Lori Shaw and Sam Gregory, who both made soccer presentations there in Boston. As always, guest suggestions, questions, and feedback are always welcome via email, expectedvalue@truemedianetworks.com. That's TRUmedianetworks.com, or on Twitter @TrueMediaSports or @Paul Carr. Please subscribe, rate, and review the show wherever you get your podcasts, and continue to spread the word as much as possible. For Albert Larcata and everyone here at True Media Networks, I'm Paul Carr. Thanks for listening to the Expected Value Podcast.